welcome back. If you're here after watching the video where we talked about the different branches of AI, or if you're landing on this page for the first time and want to learn about NLP, then you're in the right place. NLP, as you may know, stands for Natural Language Processing. In this video, we'll discuss what NLP is, how it works, some examples, and a few applications. This video is about 10 minutes in length, but stick around, there are interesting details you'll learn. If you wish to jump to specific topics, the description below captures the timestamps. And as always, don't forget to download the interactive PDF linked in the description below so that you can take valuable notes on key points to take away from this video and add to your collection of cheat sheets. Let's get started. So we all know that humans have always been able to communicate with each other through a common language. And we've always been able to breeze past differences or errors in speech, such as mispronunciations, accent changes, different contexts, slang, slurs, homophones, etc. All differences aside, we're still able to understand each other. This is what makes humans and human language so powerful. But what about computers? Well, you might argue that computers have had the capability to understand language, as in their own machine language, more commonly known as code. But since humans have to manually write all this code, it makes the language extremely limited in vocabulary and severely restricted. For example, if a programmer makes a small spelling or syntax error, the program will crash and the problem won't be solved. To better understand the big issue with these limitations, I want you to picture this. Nick here is a vet, and over the past few weeks, he has observed that many of his patients have been getting a new illness. To warn other pet owners about this disease and prevent other pets from contracting it, he wants to figure out exactly why and under what conditions animals get the disease by analyzing his previous cases, as well as cases on the internet. So he starts to look at his data. Pictures, notes, sketches, essays, voice recordings, and more. Suddenly, he feels overwhelmed because going through and making sense out of all of this data will take ages, and the worst part is, your computer or any other technology can't exactly help you. You see, Nick knows that in the documents, foot is referring to the part of the body, and not the unit of measurement, and that date means a specific point in time, rather than the fruit. But a computer doesn't know how to decide this because it can't understand the context that the words are in. After all, understanding a word all boils down to understanding the words around it, because a word by itself doesn't have much significance. It depends on the context that it's in. Because of this, the computer can't really make sense out of the data, and ultimately can't help Nick. But given how powerful computers are in terms of memory, speed, and intelligence, imagine just how much more useful they could become if there was some way for them to understand and process our language instead of only incomprehensible ones and zeros. Well, no need to dream about this anymore, because with natural language processing, this is the new reality. With NLP, new doors open. Nick can now analyze the heaps of unstructured data within minutes. Smart assistants like Siri and Alexa can understand our words and context clues to improve our lives. Google can not only predict results as we start typing in the search bar, but can also look at the whole picture and recognize more than just the words we type. Our phones and computers can predict what we'll type, finish our sentences, and suggest relevant words. NLP can solve bigger problems as well, such as crimes and even diseases, by identifying clues and patterns in emails and written reports. So as you can see, NLP is extremely powerful, and if harnessed correctly, can improve our lives manyfold. Now that you know what NLP is, how does it actually work? Well, let's dive in. Every day, we each say hundreds of sentences and talk to many different people. And in school, we all learned about the parts of a sentence and which type of words come together to create a sentence that makes sense. We know that a sentence is ultimately made up of a noun phrase and a verb phrase, but we can break the noun and verb phrases up into individual parts of speech. For example, in the sentence, "The man leaves the bank," the is an article, man is a noun, leaves is a verb, the is an article, and bank is a noun. From here, we can combine the and man into a noun phrase, and the and bank into another noun phrase. The verb leaves and this noun phrase can turn into a verb phrase, and finally, this noun phrase and this verb phrase can become a full sentence. The techniques used to create this parse tree broadly fall into the categories of part-of-speech tagging and chunking. Now, you might be wondering why I'm taking you back to elementary school. But it's because these parts of speech are what give natural language processing the power of understanding context. While an ancient computer might have been confused as to whether the word leaves is referring to the act of exiting a place or the plural of leaf, and whether the word bank is referring to a building that stores money or the land next to a river, a computer powered by NLP will see the fact that leaves in this context has to be a verb and not a noun. By analyzing hundreds of sentences and different word patterns, it can figure out that it is far more uncommon for a person to say that they're leaving a bank of a river than it is to say leaving a bank that stores money. So it must be this bank. A computer can then see that the main subject of this sentence is the man, and that he is doing the action of leaving a place, which in this case is a bank. And it's not just part of speech tagging and chunking that allow NLP to figure out the meaning of a person's words. There are also other techniques, some briefly mentioned in one of the intro videos, that can broadly be classified into two categories, syntax and semantics. More on these in the next couple of minutes. It's these individual words, their parts of speech, and their placement in the sentence that give the computer knowledge and context as to what the sentence is really trying to say. Now, you might be wondering, well, that makes sense, but how does the computer actually know what the parts of speech are? And how does it figure all this out, even if it does know the parts of speech? Well, that's where the power of today's society comes in, specifically the power of all the big data that's available in today's world. So in today's world, there's just so much data available. Basically, a programmer can gather up all sorts of words, phrases, sentences, grammatical rules, word structures, and input all this data into an algorithm. Using this information, the algorithm can figure out what kind of words usually end up next to each other, how a sentence should be formed, why certain words fit into a sentence better than others, etc., etc. And this is precisely how a computer will eventually figure out that leaves is a better fit than leaves in the sentence from before. Now back to what I mentioned a couple minutes ago, syntax and semantics, the broad categories under which NLP's techniques fall. Let's take a look at these now. So tokenization can be split into two categories, sentence tokenization and word tokenization. Sentence tokenization is separating a paragraph into distinct sentences, and word tokenization is separating a sentence into distinct words. This allows the computer to learn the potential meanings and purpose of each unique word. Next, we have stemming. Stemming is the process of reducing a word to its root, or stem. It does this by chopping off universal prefixes and suffixes, such as es, s, ing, and ed. Stemming is a powerful technique, but this crude chopping solely based on common prefixes and suffixes sometimes cuts necessary components of a root and changes the meaning of the original word. Well, this takes us to our next technique, which helps solve this problem. Instead of chopping off beginnings and endings, lemmatization reduces a word to its root form by analyzing the word morphologically. Let's take a look at what this means. So if I have the words am, are, and is, the root form of these words is be, which can be observed through lemmatization. Stemming, on the other hand, would not have been able to figure this out, as chopping off any letters would not have outputted be. Now for semantics. So named entity recognition allows the machine to categorize specific words in a sentence. This is especially helpful for words such as Google, which can be referred to as an organization or a verb. And finally, for natural language generation. NLG is a process through which a machine produces natural human language. It uses math formulas and numerical info to extract patterns in data from any given database and output understandable human language text. And to summarize, natural language processing enables a machine to take what you're saying, make sense out of it, and formulate a statement of its own to respond back to you. As we've seen, it uses a variety of techniques to accomplish this, part of speech tagging, tokenization, stemming, lemmatization, named entity recognition, and natural language generation. As a result, NLP allows computers to understand context and meaning of our words. So now you know what NLP is and how it works, but there's still one question left. How is the computer even able to understand the sounds coming out of your mouth in the first place? Or in other words, recognize your speech? Well, this is exactly what we'll be talking about in the next video, so stay tuned for that. If you've learned something from this video, then be sure to give it a thumbs up and comment down below any other words that you can think of that might confuse a non-NLP bot, such as the one from the example above, leaves or leaves. And if you're new here, then make sure to subscribe and turn on notifications so that you don't miss any videos that'll help you on your journey towards mastering artificial intelligence, as well as the chance to win cool prizes from time to time. Thanks for watching, and I'll see you in the next one.